2560 watt-hours of energy? Aurora claims that this battery packs 2560 watt-hours of energy, but can it actually deliver? We're going to confirm if this capacity claim is fact or lamba. Lamba being the local slang for fiction in Nigeria. At 12.8 volts, this product offers a lithium option 1-to-1 replacement for most applications currently using lead acid batteries. This comes in handy for applications like what you have in trucks, forklifts, and golf carts. If you want the benefits of a lithium battery for these traditional lead acid applications, this would be a good product, provided it's lamba proof, of course. So today, we will drain this battery to zero to find out if it's up to the advertised specification. Stick with us to the end of the video for the test results and verdict. And as a bonus, we'll give you some tips on how to keep your typical lithium battery working for as long as possible.
And here's our gear. Firstly, we have a fully charged Aurora Whr LFP 128200 battery. This is a 2.56 kilowatt hour lithium battery forming our device on the test. We have a Whr PZEM 017 DC communications box, and we have a PC running an IoT software stack consisting Node-RED, InfluxDB, and Grafana. Specifically, the Node-RED picks up Modbus sensor readings from the DC communications box. The InfluxDB archives the measurement collected, and the Grafana provides visualization and interrogation capabilities for the test data. Then thirdly, we have a loading arrangement consisting a MoPower inverter and an inverter air conditioning system. This is the setup with the battery and inverter already connected. The power measurement box is properly hooked up and the inverter and load is good to go. The battery is also confirmed to be fully charged. We see Node-RED is receiving the readings from the Whr power measurement box. Influx is also properly primed and receiving measurements from Node-RED. And our Grafana dashboard is successfully gathering data from Influx. In fact, from this data visible on Grafana, we can gather that the energy at the start of the test is 0 watt-hours. The results are now in. The test commenced at 12:09 hours. The battery BMS disconnected the battery at 17:55 hours. This gives a total runtime of 5 hours 45 minutes, which is approximately 345 minutes. We were able to achieve a relatively steady current draw from the AC unit with a thermostat setting between 27 and 28 degrees. This corresponded to a battery running current between 28 to 46 amperes. The energy drained from the battery at the initial battery trip-off was 2426 watt-hours. This is approximately 95% of the advertised value of 2560 watt-hours. With all errors and omissions accepted, the graph bound by the yellow line is the discharge profile of the Aurora Whr LFP 128200 battery. This graph shows the 0 watt-hour energy recorded at the onset of the discharge and the accumulation of the energy as the battery goes discharged to the tune of 2426 watt-hours over a 5-hour period. The graph also captures the battery voltage and discharge current during the interval. These are represented by the orange and green lines respectively.
As we prepare to review the performance of this Aurora battery, please bear the following in mind. We'll be going according to the ISO 12405 standard, which requires the capacity rating to be within at least 5% of the advertised value. This Western standard, which originates from the US, is mirrored in other domains, including the Chinese GB/T 31484 standard. That's the standard there on the screen right there. This product is actually okay. There's no lambda detected here. Coming in at 95% of the advertised capacity as per this test, this lithium battery is actually proving to be well within the tolerance of the advertised capacity. Yeah, honestly, I'm not sure if I'm to be happy about this, but kudos to Aurora. Accurate claim on this one. Yep.
And now for a few tips on how to maintain your lithium batteries in tip-top shape. Regarding storage, if your system will be unused for a while, say during a vacation, it pays to leave the battery in approximately 50% state of charge. Lithium batteries prefer moderate temperatures. Hence, storage indoors, especially away from direct sunlight, helps. Temperatures well above or below 25 degrees centigrade is bad for battery longevity. Where you have the option, try to do the standard charging protocol as much as possible. Frequent fast charging of lithium batteries may reduce the shelf life. Standard charging is easier on the battery. Finally, although lithium batteries can tolerate drainage to 0%, recharging from the 20 to 30% state of charge has been known to extend battery life. These are measures that will extend the shelf life of your battery.
If you found this useful, smash the like button and subscribe to the channel for more of the same content. Please post your comments. Let us know what else you would like tested on the channel. Stay powered and see you in the next video. Bye guys.